just going to comment on a fairly convenient theorem that we have in math when dealing with logarithms. It's called the change of base theorem, and essentially what it allows us to do is evaluate logarithms, say something like log base 2, of 7, which, by the way, when you think about this our base here is 2. We're really asking the question, 2 to what power turned it into 7? So, you could think like, well, 2 to the second power, that'd be 4. 2 to the third power, that'd be 8. It's somewhere between 2 and 3, this number right here. But, I want to be able to determine this. So how could I do this using a calculator? Well, the thing is, unfortunately, I'll pull out my calculator here. It's just the computer calculator. I have an ln button on it, and I have a log base 10 button on it. This is very nice. You won't see this a lot on calculators, but I have a log base 2 button, which is kind of cheating actually, because I'm using a log base 2 example here. But for the most part, you'll find that calculators only have these two buttons, a log base 10, which is our common log, and log base e, or natural log buttons. And so, typically I cannot type in log base 2 of 7 unless I have a calculator that, gives us that function. So for now, what we could say is, well, using the change of base theorem, it basically says if you had some log base a of x, we're saying this, a to the power of what turned into x, we can rewrite this as log base b of x over log base b of a. And you'll notice here that the important thing is this, that as long as these two bases are the same, then we can rewrite this as the log of this like bigger quantity here. I don't want to say the bigger like in terms of size or magnitude, but the way we write it. So the thing we're taking the log of, so we say the log of that on top over the log of its base, on the bottom, so long as these bases are the same. So like this means we could make them both base 10, which these are both base 10. We don't write those, but they are base 10 by default, or we say we could make them both log base e. So this is really the same thing as, log base e of x over log base e of a. This is what this says. But basically, you could rewrite any log this way and evaluate it. So for instance here, I could say, well, then this would have to be, by all rights, the same as log base 10 of 7 over log base 10 of 2, which you'll notice that I kind of designated this log, common log version of it. You can use ln. I actually prefer ln, but we could write this as ln 7 over ln of 2, but this is going to give us what we're looking for here. So, even with my calculator here, I could say, well, 7 ln, and I want to store this number, so memory plus, and then we say ln2, so we say 2 ln. If I divided that, sorry, I have to do this kind of a backwards way. We say by the number I got first and then reciprocate that here. But basically I would have gotten 2.807-ish. So we say approximately 2.807, which by the way is this quantity we predicted we would get here. So we'd say the 2 to the 2.807 should approximately equal 7. Let's just go ahead and check this here. So we say 2 to the power of 2.807, we should get sufficiently close to 7, which we did. Okay. So really quickly here, if I had a calculator, how would I evaluate these? I'd say, well, this is the same thing as log 25 over log 4. Okay. Or this one here, we could say this is the same thing as, maybe use ln's, ln 12 over ln 2. But basically, we could do this on a calculator pretty stinking easily now. So we'd say, I'm going to do log 4 here first. We say, oops, clear, 4 log. And then I'm going to say, okay, I'll store that in the memory here. And I'll say log 25. So we say 25 common log divided by what I had in my memory here. And I get this here, 0.549-ish. 0.549-ish. And actually, that doesn't make a whole lot of sense to me. Let's try this again here. We say 25 log of that. Now, when we did the log of 4, we say 4 log. Okay, so memory plus. We'll store that in the memory. And then we say 25 log divided by memory recall. I'm just not getting the memory to work out for me here. But essentially, if I could get my calculator to work for me here, you guys, we would see that we have this here. Sorry, I just had a reminder go off. But these will allow us to do this on a calculator and allow us to find these values. Like, for instance, 4 to what power equals 25, or 2 to what power equals 12. We could evaluate this on a calculator. Okay. Cheers.